Welcome to talks by members of the Survey and Cartography section of the National Speleological Society. These videos are intended to be how-to videos on cave survey software and other programs used by cavers in the exploration and documentation of the world beneath our feet. So it may occur to me that maybe not everybody even knows what GIS is. GIS isn't a piece of software only. It involves data, it involves people, it involves place, but all of these things center around these themes of creating data, combining data, doing analysis of data, and this kind of Rosetta Stone of all of these activities. I think also fairly, GIS has been characterized over the years as a really fast way to make bad maps, and there's a lot of truth in that statement. Um, Almost never do you want to take the default settings that you get out of a program like GIS. They are simply that, a starting point, a default. But if you're always using default settings in terms of making your maps, representing your data, you're really missing out on a lot of the capabilities of the software, not only in terms of making more aesthetically pleasing maps, the idea of cartography, but also just understanding your data and getting the most out of your data rather than just kind of skimming along the surface of a tool like GIS. So you just got the 110,000 foot view of GIS. The program that I'm talking about tonight is called Qgis Quantum Gis. Qgis has really developed, enhanced their feature set a lot more in, say, the last 5 years to be a viable alternative to some of the more proprietary GIS software that's out there. And most of that market share is captured by a piece of software called ArcGIS. We'll have some future talks on ArcGIS as well for those of you that want to use that software suite. But tonight is Qgis. Qgis is free to download. They certainly take donations to support the cause. But one of the nice things about Qgis that ArcGIS cannot do is run on multiple platforms. So if you're a Mac person, you can load Qgis natively on Mac, on Linux, and Windows, of course. But they also have apps that run on Android and iOS. They're not as full featured as the desktop, but certainly if you want to collect cave data on your Android phone or your iPhone or your tablet, you can do that with Qgis as well. The version I'll be showing tonight is the newest release, 3.12.1. You can download it here, and I'll make all these slides available after the fact with the YouTube recording. Or you can just go on Google and type in Qgis download, and it'll take you right to the page. You don't have to remember all of this. So our topics for tonight, at a minimum, I'm hoping to cover these 9 or 10 topics, how we're going to open a shapefile, and we'll learn a little bit about shapefiles. I say shapefile here because that's one of the formats that's seems to be common between various cave survey programs as an output option. So if you're using Compass, if you're using Walls, if you're using some of the other cave survey software, some of which come out of Europe, they all seem to be able to produce a shapefile. And a shapefile is something that can be used inside of GIS. So it's this, like, think of it as a least common denominator between some of these programs, or an interchange almost file format. We'll talk about how to take data out of the Qgis software and put it into a format called KML, or Keyhole Markup Language. This is the format that Google Earth uses. So if you've ever been in a position where you wanted to use or show your line plot of your cave in Google Earth, you'll learn how to do that tonight. So you'll be able to go from Compass or Walls, let's say, or Therion, or even Caveware. I think I'll do a shapefile now. And you'll be able to go into Qgis and then come out of Qgis with a KML. We'll talk about how to load background map layers. So one of the big challenges for cavers, especially internationally, is if you work and do exploration in areas that don't have good imagery. And this is almost, everywhere except the developed world. So if you work in the US, you work in Europe, you might be able to find some imagery. But if you're working in Myanmar, you're working in Ecuador, you're working in even Mexico, imagery can really be more of a challenge. And moreover, if you find imagery, you're probably only going to find it from one source. And so tonight we'll talk about how you can find some different sources, be able to compare those sources to each other, and then make your choices based on best available imagery, not only available imagery. We'll talk about how to select features and save those out to a separate layer. We'll look at some labeling. We'll look at exporting SVG PDF. These are both formats that are supported by Illustrator. If you are drafting in Illustrator, you can output data from QGIS to that format. And then we'll wrap up talking about how to pull in data from a GPS via the GPX format, and then how you might want to draw things like trails or other features you want to look at, and then export those back out to GPX, which you can upload to your GPS and have a map on your GPS. And then finally, we'll talk a little bit about print layouts and what those entail. So that's it for PowerPoint. Let's jump over to some software here. So whenever we start GIS, we got a couple of people here wanting in on the meeting. Let me make sure that they are able to get in. Okay. When you start up QGIS, this is the window you'll see. And so this is kind of the introductory window. Your window sizes and things may be slightly different, but this is the basic look and feel of the data. And so here I've got what's called the data browser. And then I have another panel called layers. Right now there are no layers loaded in my map because I don't even have a map. And so the only option I really have here is to start a new empty project in QGIS. So usually one of the first things that people want to do is add their shapefile to the map. And so if you have your shapefile, you can go to whatever folder that shapefile might be in. Here's a shapefile of a make-believe cave that I made up, and I can add that to the map. And then I output this data from walls. So here's our stations that go along with that shapefile. And so as long as you have a shapefile out of whatever program you have, it's quite easy to add that into GIS. And so I can zoom in, zoom out on this data. I can pan around and move that data around with the pan tool. I can window in using the magnifier to a specific area. And I can also select features. So I can say, okay, what's going on with this set of features? Now, one of the things that's often problematic is that the highlight color doesn't show up well for some people. And so what I'm looking at is a need here. Maybe I don't really like this yellow color that's being used to highlight. Every project that you have in QGIS has what's called project properties. And one of the many project properties you have here is the ability to change your highlight color, or what's called the selection color in QGIS. You can also change your background color if you want to make that black or something non-white. And there's obviously a lot more settings in here. We're not going to go through all these tonight, because when we get into doing all of these things at once is where we start hitting that wall, where we start hitting that tidal wave of trying to understand it all. So we're only going to hit on a couple things here in the time frame that we have, and then we'll build on that in future sessions if people are interested in learning more about some of these software tools. So I can change this, click OK, and now whenever I highlight things, I might be able to see that color easier on my map. You'll see why I did that in just a second, because when we start putting an aerial photo underneath all of this data, it's going to really help us pop the lines out whenever we select them. So let's talk about this idea of adding base maps underneath. QGIS supports something called a tile service, XYZ tiles. And it may or may not come with some that are preloaded. I think some versions of QGIS come with Google Maps loaded or something like that. But most cave survey software doesn't allow you to use tile data in the background, at least not that I'm aware of. And even ArcGIS, the company that manufactures ArcGIS, provides their own imagery services, and most people use those services versus using other things that might be available. The example that we used here was the Google Maps. And so I've created a document that has some of these endpoints for links to different mapping services. So if we want to grab the Google satellite data, all I need to do is copy this string and then come to my XYZ tiles, say I want to set up a new connection. I give that connection a name. And then where it says URL, I just paste in that ugly string that came through from the text file. What's happening here is that the application is passing an XYZ coordinate pair back to the Google server, and then the Google server is sending back the imagery for that particular coordinate. So when we click OK here, we now see that in our data browser, and if I want to add that to my map, I drag and drop. And now I have a image or Google aerial on here. The problem is I can't see my cave data anymore. But if I come to my layers, what I'll notice is that the Google aerials are on top of, if you want to think about it in those terms, my cave data. So if I just left mouse click and drag that to the bottom of the list, now I can see my cave data a little bit easier. And say, well, that, those colors are a little hard to see kind of behind the scenes there. I can double click on any of the color swatches in my table of contents, and I can change the color, and I can also change the line width to be something that shows up more easily on top of my aerial photo. And I can zoom in and zoom out on this data as well. Likewise for my point features, if I double click on my point features, I should be able to not only change the color, but I can go through and find all the different symbols that are available in the library here. I can set the size of those symbols. Click OK, and now I've got that data on my map as well. So, just with a couple of clicks here, we're able to take data out of our cave survey software, and we're able to put it back into GIS along with a base map that might underlie this. Now, this cave is a real cave. It's not here. The location I put this cave in was on the corner of this lake that's out in the middle of Kansas. Maybe there's a cave there. Good luck if you want to go try to find one. I seriously doubt it though. But if we had the geology map, we would be able to slide that underneath this map as well. So, what if we don't want Google aerials? What if we want, Bing Maps, or we want another data source? I put a couple of these in here for you, but probably more to the point is that we can take a script. And so here's a script. I didn't write this, somebody else did. But we can just take this entire script and copy this script, and then come to our Python console inside of GIS. You're going to run some Python here. You'll just see how amazing it is. But so let's watch right here on XYZ tiles. When we run this script, we immediately get all of these background layers now are available to us in GIS. So if it's not Google, if I'm looking at Google Earth, and then I want to compare that to Bing, let's say, I can add the Bing map data in here as well. And I see those two layers here. So I can toggle back and forth between the Bing data and the Google data and see which one I want to use for my particular caving area. All of these data are going to be collected at different times of the year under different moisture conditions. So they will be different, and they're collected at different times. I was looking earlier. If you find yourself working in a region of the country or the earth that's under intense development, having imagery that's just a couple years apart might be a really big deal. So some of us that are on the call, I saw, and myself and others have worked um, in the along the Mayan Riviera in south of Cancun, Mexico. And if we look at different data sources that might be available in any given area, some of that data is going to be better than others. And so if we want to try to evaluate which of the data sets that we're going to bring to bear on our particular project, let's add in a couple others here. And we'll grab the Esri data as well. You know, we can toggle back and forth and see that there's a big difference in the amount of development that's shown on each of these. Now, I can keep doing this toggle thing, but that gets kind of old after a while, and you might click on it too many times like I just did or something like that. And so one of the really cool things about QGIS is it supports something called plugins. And these are little add-on programs that we might want to add to our map. And one of those tools is called Swipe or MapSwipe. So I'm going to install that plugin. That's how easy it is to install the plugin. And then that's available to me on my map bar. And so what does this plugin do for me is I can do this swipe now, and I can compare individual areas while I'm on my image rather than clicking on something in my table of contents. So I can see what's going on, you know, and say, okay, it looks to me like the Google satellite is showing more development than the Bing imagery. So we're looking at these two layers that are on right here. Now I can add the Esri satellite data on top of that, and then we can swipe that and then say, well, there's no difference I'm seeing there, and that tells me that Esri and Google are using the same source imagery for their image services. So if you find the one that you want, then you can just right mouse click on the ones that you don't want, and you can remove those to save yourself the additional overhead here, not only in your project, but once you start building up a project, you'll probably have dozens of layers here in your layers pane, and it just kind of helps keep things simpler. So we can remove those layers easily, and then, you know, at some point you may want to look at other interesting layers. If you're making a site map, let's say you're going to publish a map in the NSS News or somewhere else, and you just want to have a site map that shows us a location map, you know, I might want to kind of get in the vicinity of where I'm caving, and the right tool for that might be one of these black and white maps. And with the toner maps, you know, I get something that looks more like this. Or there are others in here that are probably a little bit better than that. Let's see here. Openstreetmap Monochrome is a pretty good map as well. So you can make your location map, you know, your inset, and add that into your project as well. Whether that, like, you know, I mentioned publication, but this could also be something that just goes on to your whatever map you're drafting as an inset map or something like that. So pretty easy to add these services in, and if there's things in here that you just never use, you can definitely remove those as well. I was looking earlier, and some of you that exercise might be familiar with the Strava data. I was looking. Let's turn off. Let's see. Oh, I didn't add it. Looks like it's having some problems with the Strava server right now. This is all the biking and walking data and stuff for the whole world. That, oh, there's some of it. So yeah, you can see all the biking and walking data here in your project as well. Probably not for caving, but you know, if you get going with GIS, it's easy to start using it for other things as well. I should also say you don't have to do all of these one by one. Like I said, once you've figured out the one you want, you might want to just take all these, highlight them, and remove them all at once. It'll say you're removing 3 legend items, and there you go. Okay, so that's how we open shapefiles. That's how we add Google Maps, add Bing Maps, other types of imagery stuff. And then I also threw in the MapSwipe plugin and the Python script to add all the background layers. Those are things that you know, that everybody can do. As I said, I didn't write the script. One of the things you'll learn about the GIS community, much like the caving community, is everybody's super helpful. If you hit a roadblock or you need a helping hand to get over a programming issue you're having or something, the news groups and different sites are always going to be one of your first starting points. If you and somebody, you know, is written a script or something that they're happy to share with you. So let's turn our cave survey back on here. And one of the things that we might want to do is label all of our stations. So if I double click here, I'll get all of the properties, what's called the symbology for that particular layer. And at that point, you know, I can come to the labels and say, there are no labels now. What do you want to do with that? I want to add a single label, and I'm going to put the station name in that. But these are all the, you know, I can label every station with its left, right, up, and down, or its azimuth, or whatever I would want to do there. I can pick the scale, I can pick fonts and all that kind of thing. I'm going to go ahead and add these on here and say, okay, I added that on there. I see 2 problems straight away. The first one is that the text is kind of small. The second one is I can't read it because it's black on a very dark aerial photo background. So the way I would fix that problem, again, is open this panel back up and say, okay, I'm going to make that text white, and I want to take the size, and I'm going to, in fact, if I move this over, you'll see the size changes as soon as we add that back in. So now I can see all of my stations much easier, and look at wherever my end of survey is at, or where my next lead might be at, and go from there. So really powerful ability to label features once you've got your data in there. This is a pretty small, pretty simple cave, but you can see hopefully some of the benefits of doing something like that. Right now I'm going to turn those labels back off though, because they're kind of cluttering up my map for some of the next things that I want to show you. And the way I can turn those off is just go back to no labels for this particular layer. So we've got some cave data, we've got a background. I might want to even turn off my survey stations if I'm just looking at the line plot, trying to understand more things about my cave. And GIS is a good place to do that. You know, I was maybe having a conversation with some of my friends, and somebody on the survey crew said, you know, it really seemed like we took a lot of compass shots that went in a particular direction. And, you know, what's going on with that? In the past, we would have tried to look at that through something like a Rosetta diagram where we're plotting vectors in opposite ways and stuff. But that doesn't tell you where those vectors are in the cave system. It just tells you how many, what the frequency count of them are. Let's say we wanted to highlight our map with a particular range of azimuth values and try to glean some, you know, something about that off the map that we have. In GIS, we can select features by a value. And so here we might want to select the features, you know, based on a particular name, on a particular other value that we have in here. But we might also want to go to a range of features. And so we can say, okay, let's do some basic arithmetic here and look at what we might be able to pull out of our data. So I think I removed the, oh, you know what? Let's go to this data set. So here we'll be able to pick out, yeah, by azimuth. Now, I may not know an exact azimuth, or moreover, I probably want to be able to say, you know, plus or minus 5 degrees of something. And so that's why if I know an exact number, 1, 2, 3, if I happen to have an azimuth that's 1, 2, 3 or more than one, all of those would highlight on my map. But that's not usually how it works. And so that's where you want to use your expressions and say, okay, I want to pick everywhere where the azimuth is, let's say, and we have a whole set of operators here as well. Everywhere where the azimuth is greater than, say, 60 degrees. So we can type that in and we can select those features, and we see that we have highlighting vectors that match that particular criteria. Or we can say is less than and equal to a value and then greater than and equal to another value. Or let's say something from a management kind of perspective, or maybe even a rescue perspective. The manager comes and says, I need to know all of the areas in that cave that are walking high passage. And you say, well, I'm not sure, you know, I can sit down and I can highlight that information. Or you can use GIS to help you try to answer that question. So let's clear out our last selection and let's build a new selection set from here. So I'm going to say, okay, instead of trying to figure that out from my vectors or my survey shots, I'm going to go back to my station data where I have LRUDs, and I'm going to build an expression here that says where the up plus the down is greater than 2. So this data is in meters. So 2 is about 6.5 feet. We'll call that walking high. The great thing is that you can change this value, and I'll show you that in just a second. And so you can say, okay, I'm making this assumption that anything that's at least 2 meters high is passage that people can move easily, or, you know, the term that cavers use is walk, but it's not always walking. We all understand that, hopefully. But I can add that data back to my map, and all the stations that highlight in pink meet that criteria. So I can see some stretches that might be walking high. So down here, for example, if we have to navigate, and I can tell you, and we could also run a query on this, but I'll just tell you, this loop connects around here. But if we're evacuating somebody out of the cave, I would be able to bring that data in, or I'm sorry, bring the patient out through the walking passage instead of going through the passage where they might not be able to walk. You know, if somebody says, well, you know, I think we can move the patient or move the equipment, maybe we're doing some science experiment, maybe it's not a rescue situation, but I need at least 1 meter high passage to set up my, you know, my scientific experiment. I just change this number to 1 and rerun my query, and, you know, and it doesn't look like it here because these are already meeting that criteria, but some of these other dots here light up and say, okay, these are also candidate stations where I might want to you know, set up my scientific experiment. So from there, I'd say, okay, now let's go back to our data that we were looking at, turn those labels back on, and now I can show this map to the scientist and say, okay, everything that's highlighted in purple here meets the criteria for your scientific experiment, and you can go ahead and take this with you into the cave, look for our stations, and it should meet whatever criteria you have. So that's a couple different ways that we can select features. Anytime that you're selecting features, you also have the ability to take those features and save them out as a different layer. So let's say we wanted to make a science layer out of those selected features. All I need to do is toggle this and give it a name. So I'm going to change it back to being a shapefile. The one trick I'll tell you right here on the file name is you never just want to type in just a file name here. And the reason for that, I'll do it here and you'll see what happens. We'll get, of course now it's going to work. Usually what'll happen here is that if you're pulling in data from different folders, you'll get an error message saying it can't save that information. And the reason for that is that it doesn't have a path. And so as a good kind of go by or practice is anytime you're exporting data, make sure you use the little ellipses here and select a full path to wherever you want to save your data. And that whole path will show up in your box right here. And then you should never get an error message as long as you have write permissions and so forth. So that was just one little tip I wanted to share. But if you look closely, we have a new set of dots here that are only those science stations that met our criteria. They have a new name, and then we can do something else with that data from here if we wanted to. So what if we want to take this information, let's say we're not so worried about the stations right now, but we want to take our information that we have and we want to export that out as a KML file. Well, we'd use that same basic procedure where we go to export, save features as, and here instead of our shapefile, we'll come down and find that KML. It's not going to be called Google Earth. It's not going to be called Google Maps. It's the keyhole markup language. So make a note of that. You'll pick that, and then you'll give that a file name. Again, best practice is to give it a name that's in a full path. Here's my KML, KMZ. A KMZ file is just a zipped up KML file, by the way. You can actually unzip it with any zip utility, and it'll open up as a KML file. But we'll save that off. You'll see that the whole path shows up in my line here, and there's no need to add that to the map because it's not needed. That's saved off, and then that's a file I can use and open up in Google Earth. Or if I've got another program that can also read KML files, that might be my trick to getting data out of the Qgis format or software over into something that a different program might be able to read. So let's move on then and talk here. We've got about 15 or 20 minutes left. Let's talk about GPX or GPS files, and then also I want to get to the Illustrator and the print layout, which are kind of tied together. So I have another file here that I'm going to add a new layer, and it's going to be a vector layer. And one of the things about the vector add data is that you can either pick by format or you can just throw the whole kitchen sink in there. This is, I don't know about you, but this is pretty overwhelming. So if you want to go down and find the GPS exchange format, you can do that, and then it'll filter those down to just those file formats that you're interested in. So I can add that. I see the path is added here. Add that to my map. It'll say, hey, I noticed in your GPX file that there's a lot of different kinds of data. Do you want to select only specific ones, or do you want to bring all of that data over? Most cavers will just add everything in. If you are really like tuned into your GPS and know exactly what you want out of it, then by all means you can just select one thing out of here, and that's what'll be imported, and everything else will be left behind. But as I said, most people select all and then add all of those things to their map. So we have all of these new layers. If we go and look at where those are at, should be able to. This is all the way down in the Galapagos on another project that I'm involved with. But you can see that we're bringing in GPS data here. Little hard to see that against the background. So again, that's a place where I'd probably want to come in to the symbology of my map here. Let's get rid of some of these others. So there is nothing in routes. There's nothing in points really. It's these down here that we're looking at. So I can come back to my symbology. Purple's not a good choice against the background there. We'll go with something a little more obnoxious, maybe bump it up a hair, and then we'll be able to see our routes. And so this is the main route in and out of town, and these are the different ways that our truck driver brought us in and out of town. Somebody just turned on, down here's where we stay in a hostel kind of building, and you know, so there's a lot of tracks jumping around here. But you can also check in and see how your GPS is lining up. Sometimes it's better than others. You can see here that this is the road being traveled, and the GPS has jumped off to the side here for probably 4 or 5 meters, and then it gets much closer to the EPE that most people are familiar with in the US of, say, 3 meters or so, like that. But this is just the nature of GPS data. But we can have all this data in here. And then, of course, if we go, let's go back up to our flat cave. I'm right mouse clicking, zoom to layer, is that if I want to record some of these other trails, let's say that aren't on the map, and we're going to go out and check for leads out here, I need to first create a layer to store that information, and then I need to come back in and populate it with line work. So the way we would do that is go to layer, create layer. We're going to create a new shapefile, give it a name. Maybe I'm going to call it ranch trails. What type of geometry are we going to store? We're going to store lines in this particular one. We can pick points, lines, or polygons for discrete features. I can give it attributes, but I'm not required to. So in this case, I just need some graphics to push back to my GPS. I'm going to leave all this blank. I'm just going to leave it alone. And I'm going to, oh, the other thing I want to make sure I do here is click into my path again, because that's where I'll get into trouble with errors. So clicked into my path, click OK, and we should have now ranch trails added to our map, which is right here. If we want to start editing or adding data to our map, we click on the pencil, which turns on the editing, and then we can start drawing lines on our map. So I want to add this road. And then maybe I want to add this road over here. And those are a little bit hard to see, so we're going to come back and make that something that's a little bit easier to see. You can also type in these boxes. You don't always have to use the little up and down arrows. But let's say these are 2 lines then that I want to be able to push back to my GPS. Well, I can right mouse click, use that data export, save those features. And here, all I need to do is change my file format back over to GPX, give that a name. So here we are. Name that one Ranch Trails, whatever, you know, put a date on it. However your data management works, save that off, and then those 2 pieces of geometry will be saved back into your GPX file format. That I need a ID there. but I would just save those back out, and then I'd be able to upload that through whatever software your GPS interfaces with. If you're using Garmin, I believe you can use Basecamp to load GPX data back into your GPS. Okay, so then to wrap things up, we're gonna combine a couple things here that are popular for cavers to want to do, and that's to take information out of, let me save this, and then I'm gonna remove it for right now, is to take information out of here and go into Illustrator and or print. And in QGIS, all these things are handled from the same area. In ArcGIS, they'll be handled differently, and at some point we can go over that in a different session. But for QGIS, what you want to do to get started on that is to say you want to create a new print layout. You can either grab that from this icon, or you can go to Project, New Print Layout, or you can do Control P. They all get you to the same place. You have to give it a name. And once you've done that, you'll get a print layout that looks like this. And so this is just a default. Again, we talked about defaults are not usually a good place to land, but they're a good place to start. And so what we want to be able to do is start adding some data to our map. So if I want to add a map, I would come in and add that map onto my layout page. And the map is everything that's happening behind us here that is available to us. I might want to change the orientation to portrait or to do something else, but we can zoom in on the layout. We can go to 1-to-1, zoom out to the extents, and so forth. From here is where I can now save this as an SVG file, or I can save this out as a PDF file. So both of those activities happen from this location. And then you can take them into Illustrator or whatever. A lot of people, if you look online, a lot of people will export data out of QGIS as SVG and use programs like Inkscape for drafting and so forth. But the final thing there that I wanted to talk about in wrapping this up is that you can actually make a map here. Let's say you're making a map for the landowner or something. You want to add a scale bar, you want to add a north arrow. So I can add a north arrow. This is the default north arrow that comes with QGIS. So I can say either synchronize that up with the map view that I have, or if I know that, you know, magnetic, if I want to show magnetic north and that's 4.5 degrees or something like that, I can rotate my north arrow. 4.5 doesn't show up so good, 11 will show up. Yeah, so you can see the north arrows turning, or you can leave it synchronized with your map view. I think almost universally, all north arrows that come with GIS software are pretty lame. So I'm a big fan of creating your own custom north arrows. And I'll just add, I added for tonight, I created a north arrow for our work in Galapagos that we can add in to this map. It's actually on here now. The problem is that it doesn't show up well because it's on top of the aerial photo. So this is a north arrow that's made, let's move this over a little bit. This is a north arrow that's really made for putting on cave maps with the white background. But if you need to be able to put your north arrow onto a map, you can also use a you're not limited to JPEG. You could also, or sorry, SVG. You could also use a JPEG, and if you use a JPEG file format, then that white background is going to travel with your map, so you'd be able to easily see it on top of even an aerial photo that's quite densely packed. So from here, you know, I would be able to take my layout and I can save it as a PDF and SVG, or I can send it to my printer, whatever makes the most sense for me and the work that I'm continuing to do. Of course, if you save these things to PDF, then you can put that onto a phone, you can put that onto a tablet, and you could take that map back into the cave with you for exploration if you're trying to follow a line of stations, or you're taking even sketch back in with you. In a future session, I'll go over how to georeference your sketch or your cave map in GIS and be able to take that along with your aerial photo background, everything out in the field with you, whether it's doing surface work or doing in-cave work and things like that. So I think, let me check my bullet items here. I think that's the main stuff that I wanted to cover tonight, and we did that within 10 minutes of an hour. So I'm going to stop there and go back to my camera, and we can chat, and I'll try to answer any questions that that you guys might have.